Hi there. So this is just continuing on with more examples of not just quadratics, but other functions in terms of transformations. So again, as a reminder, the original like the main transformation function g of x is equal to a times f of k times x minus d plus c, where the vertical expansion or compression and reflection is represented by the a value in that function, the horizontal expansion or compression. And when we say expansion, these are a different set of notes. I'm talking about a stretch factor. So expansion and stretch are the same meaning. So the horizontal expansion or compression is shown by the k value. Vertical shift is the c value, and the horizontal shift is the d value. And now when we're graphing with more than one transformation, it's often helpful to draw the new function one step at a time. And if you're going to graph in this order, you should do it first your a value, a and k. So I'll just say a and k. So the stretches or the compressions, and then you would follow that with the c and the d values. They either shift left or right, or shift up and down, up or down. So when you're working on these functions, it's good to practice describing the transformations in words. So again, reminder, your g of x will equal your a times f times k x minus d plus c. And if you need a refresher on what each term does, there's a video a few videos ago that describe each of the transformations. So here when we have y equals 3 times x plus 6, and this is our base or parent function, then we can see that the 3 is our a value and the minus 6 is our d value. So we've got a equals 3 and d equals minus 6. So that in terms of words, we've got a vertical stretch by a factor of 3. And we have a shift to the left by 6 units. So what you should do now is you should pause the video and then start it again once you've finished these descriptions. So maybe the first thing you should do is pause it and go through and identify the different transformations. So for example, this is your k value. This is your c value. So do that for the others and then start it up again. And we'll take that out first. Great. All right, so now compare your values, your letters to the different values to see if they match up with the ones on the handout here. And then after that, you want to pause the video again and write out the transformations like I did for the first example, and then start up the video again to compare yours. Great. So maybe what I'll do is one at a time. So if you look at the first ones, you know 0.5 is 1 over 2. That's your k value, so that would result in a horizontal stretch by a factor of 2. So it's 1 over k. So 1 over 2 is equal to 2. And c is minus 4, so we would shift down 4 units. All right, so when your d equals 1, that results in a shift right by 1 unit. And when your c equals 9, you're going to shift up. The original graph will be shifted up 9 units. All right, and the next function, we've got a vertical compression by a factor of a half, 1 over 2. and we have a horizontal compression by a factor of 1/4. Now for the next function, we're simply going to shift up by 7 units. So again, pause again, and we'll do the last one. All right, and for the final element on the table, the final function on the table, your a is -1. That means a reflection in the x-axis. So it flips it over. And where your d equals 2, you're going to shift right 2 units. All right, for the next one, on page 2, to keep in mind, expand, again, is the same as stretch. So whenever you see a stretch, or compress, or expand, you know that's going to affect either the a value or the k value. And whenever you see a shift is going to affect the c value or the d value. And a reflection is always going to affect either the a or the k. It simply makes them negative. Yes. So if we want to stretch vertically by a factor of 5, so stretching vertically is your a value, and you shift 8 units up, that's your c value. So if you have y equals f of x, that will result in the function looking like y equals 5 f of x plus c. 8. I don't know why I put it. Yes, 8, because there's an actual number. That's right. Now if we compress vertically by a factor of 0.4, then we would have, this is your a value, and you're going to shift right 3 units, that's your d value. So that's going to be 0.4. Now f x minus 3, and that's your transformed function. So why don't you pause the video and determine what values affect what. So the next one, actually, I'll just go over the next one. So when we stretch horizontally by a factor of 3, that's your k value, but your k value is actually 1 over that. So it would be, and I'm sorry, shift down, just to complete that, is your c value. So that would look like, instead of 3, it's going to be 1 over 3. X. And shift down, so it's going to be minus 6. Okay, so pause the video and try the rest. And remember, whenever you have the k value, you flip it in the actual transformation function. All right, so continuing from D, if you compress horizontally by a factor of 1/2, that means your k is 2. And you're going to shift 4 units up, that means your d is 4. So therefore the transform function would be f 2x minus 4, and that's that. And next, if you shift 10 units to the right, oh, hang on, slight mistake. When you're shifting 4 units to the left, that means your d is negative 4. So then this would become positive. Sorry about that. Now here, shift 10 units to the right. That means here your d value is 10. 5 units up, your c value is 5. So your transform function would look like f, and here we have x minus 10 plus 5. And then finally here in the last one, reflecting the x-axis means your a value is negative 1. Shift 1 unit left means your d value is negative 1 as well. So the transform function would look like y equals negative f of x plus 1. All right.